3.3, solving systems by elimination. Read and highlight. Let's go to work. As we begin, I do want to put on my own twist here. Sometimes I'll call this elimination, aka, aka also known as the addition method. Okay, the addition method. Sometimes I'll call it the addition method just by accident or by habit, because that's what it was called whenever. I know, I'm old, but when I was a kid, that's what it was called, the addition method, because you add the two equations together. I'll talk about that when we get a little bit closer. Let me grab my highlighter here, and we'll begin our reading and highlighting of section 3.3. Sometimes it's easier to eliminate a variable entirely from a system rather than to use the substitution. We do this by adding opposite coefficients together to get a zero of one variable. That's why we sometimes call it the addition method. Okay. Subtracting to eliminate. First, we need to decide which variable is easiest to eliminate. You can see right there that those variables are the same. So we consider the following system. Notice that in this case, the coefficients for x are the same. This means that they will be easily eliminated. If we subtract 3x from both sides of the first equation, we can eliminate the variable from the left side, but we'll still have x or the right side. Left side, but still have x on the right side. However, if we subtracted 3x plus 2y from the left side, we could then subtract 4 from the right side, because we know that 3x plus 2y is exactly equal to 4, thanks to the second equation. Remember that if we're going to solve a system of equations, we have to use both equations somehow, which is what we just did. This sort of like repossession in a way. If you don't have the money to pay the bank, they can repossess your property up to an equivalent value of what you owe. There's a real life lesson for you. Make sure you have it, because they'll take your stuff from you. Okay. In the same way, we don't want to take away 3x plus 2y from the right side. We can take away something equivalent, which is 4 in this case. So let's take a look. They're going to basically, we are subtracting everything. Subtracting the 3. We're subtracting the 3x. We're subtracting the 2y, and we're subtracting the 4. See that right there? They're subtracting everything. So 3x minus 3x cancels. 1y minus 2y is a negative 1y. And then 1 minus 4 is a negative 3. So 0 times anything is 0, so that's really gone. So I end up with a negative 1y equals negative 3. Notice it almost looks like we subtracted the second equation from the first. What we actually did was subtract expressions that are equal from both sides to keep the first equation balanced. Now we can solve, since we have zeros, 0x's left. Divide by a negative 1, divide by a negative 1, so x equals 3. Now that we know what y equals, we can substitute that back into the equation to find the x value at some point. So we substitute the 3 back in, subtract 3 from both sides. So 3x equals negative 2, divide by 3 on both sides, and x equals negative 2/3. So we get the solution negative 2/3, 3, which we can verify is in the second equation by substituting both in to make sure the statement is mathematically true. Adding to eliminate. Adding to eliminate. Adding to eliminate a variable will work the same way. In this case, we should find one variable with opposite coefficients of the same variable of the other. For example, we can see those two y's. If we were to add these two equations together, the y's will certainly cancel. Notice that the first equation has a 2 as a coefficient for y, and the second has a negative 2. This means that we're adding x minus 2y to the first equation. Remember, we don't want it to add up to be more of the y variable on the right side, so we add something equivalent to it. In this case, it would be 4. So basically, we're just adding this equation to that one. Okay, when that happens, 3x plus 1x is 4x, and the y's cancel. And then 4 plus 4 is 8. So we get 0 y's, and means it's gone. It's eliminated, which is what we wanted. That's why it's called the elimination method. So we now divide by 4, and x equals 2. Just like in the previous units, we'll then take that 2 and plug it back in, see what the y is. We'll leave it as an exercise to show how you can get y equals -1, which means that our solution to this system is 2, -1. Okay, well, sometimes the coefficients don't match up. The elimination works fine when the coefficients match and or are opposites. But what about when it's just a messy system of equations like this? We see that nothing matches up or cancels. Solving a system by substitution method would mean dealing with fractions and the coefficient don't match up, which makes the elimination method won't work either. However, there is a way we can get the coefficients to match. Notice that the first equation we have 2x and the second one we have 4x. Wouldn't it be nice if the first equation had a 4x instead of a 2x? Is there any way that we can make that happen? Well, sure. If we multiply both sides of the first equation by 2, we will maintain and have 4x to match on opposite sides. So let's do that. 2 times 2x is 4x. 2 times 6y. Excuse me, 2 times 3y is 6y. And 2 times a -1 is a -2. So we got an equivalent equation. Now that we have matching coefficients, we can use the elimination method to continue to solve by subtracting. 4x plus 6y from the left side of our new equation and subtracting -2 on the right side. Okay, so now that we subtract, 4x minus 4x, those cancel. 6x plus 5y, 6y minus 5y is a 1y, and a -2 minus a -1 is a -1. So y equals 1. From here, we can again substitute -1 into either original equation to find that x equals 1, which would give us the solution 1, -1. Don't forget that it is still possible to get infinitely many or no solutions to these equations. Both variables get eliminated and we down to a number that equals a number that's always true. It's infinitely many. If we get down to a number that equals a number is false, then it's no solution. So that is solving systems by elimination, reading and highlighting.